Tuesday, November 24th. I'm Jeff Hunter. Thanks for checking out the video. If you're watching this on YouTube, please thumbs up down below and subscribe down below if you like what you see, which I really hope you do. If you're watching this on LinkedIn, same thing. Please give me a follow, shoot me a message if you're interested in the content. If you have any questions about energy, environment, technology, that's sort of what I'm into, in specific heating, air conditioning, and hot water systems in buildings of all shapes and sizes. Behind me there on the TV, that's my website. It's a work in progress, but that's www.jeffwhunter.ca for more content and easy ways to connect with me. So I just wanted to put out a quick video here tonight, and just kind of a tag onto the couple of posts I had on LinkedIn this week. We kind of wrapped up, or starting to wrap up, a project in London, Ontario, a geothermal project at a high school. So it was a high school decarbonization project, decarbonizing the heating plant there. And so we supplied 2 heat recovery chillers to that. I made a comment on the one post that I just wanted to follow up on. I've been thinking about it ever since. And the comment was that that high school is now sourcing 70% of the energy it needs for the heating plant from its front yard, heating and cooling plant, perhaps. From its front yard. Now, in full transparency here, this school does still have natural gas on site. It has a boiler system on there. So there was an existing boiler system. They got rid of a bunch of the boilers and we put the heat recovery plant in place, but there's a boiler peak shave system in there. And if you look at the heating load over the course of the year, of course, it's like if you have January and December over here, it's kind of like what was that? It's like a U shape, right? And the peak shave is in there to shave off those, whatever it is, 2% of the peak time there. And what that does is have a pretty big impact on the capacity of the system required, both on the mechanical equipment side, the chiller plant, and the loop. And so that's, when you're dealing with an existing building and retrofitting existing building, you have restraints, of course, that you have to deal within. In a new building, you can design around that, and certainly you could design distribution around that. You could design, if you have room for the loop, you can put the loop under the building. There's a lot of stuff, more stuff that you can do in a new build that you can in a retro. And in this case, so we had boiler peak shave. We also had a high temperature chiller plant because the older distribution system, we had to make sure that we could get energy out of that. So that's why we kind of have we do have 2 chiller plants, heat recovery chiller plants. One is the sort of the first stage that's providing a medium grade heat to the building loop, which is then being upgraded again through a high temperature chiller plant, R134A, to like 160 degrees, which I think that R134A plant could go to 170, but it's operating around 160 in this case. So, that's something that if you're doing this from the get-go on the new design, you probably wouldn't design the distribution system to be high temp, right? And so, where was I going with that? You're kind of constrained in a retrofit situation. But it was great that we have Multistack as a supplier, because they have some really innovative solutions to be able to, number one, get the equipment into the mechanical room, which can be a challenge on its own to fit it in there. And I know that was part of the challenge in this application, to fit that capacity into the space that we have. And then 2, meet the temperature requirements. But the point I really wanted to highlight was that I mentioned in one of my posts that, that school now is sourcing 70% of its energy, BTUs, from the soccer field, where the loop is now. The loop is sitting underneath the soccer field, instead of from Pennsylvania. And what I mean by that, my understanding is that Ontario gets most of its natural gas through Pennsylvania, and Pennsylvania is active in fracking for natural gas ever since mid-late 2000s, when fracking started to become more and more popular. And I'm not a fan of fracking at all. And I'm not a fan of natural gas either, right? And the reason why I'm not a fan of those 2 systems of natural gas is for space conditioning specifically, we're heating our indoor space to 20 degrees Celsius. We're cooling it to 20, 25 degrees Celsius, whatever it is. So why do I need to combust a fuel at 2000 degrees Celsius just to get my indoor space to 20 degrees Celsius? So that's why I think heat pumps are the technology that we should be using. And specifically, geothermal loops on ground source heat pumps, having that loop field there available any time of day, any time of year, at point of use, on demand, ready to go, push a button. As soon as that chiller system, heat recovered chiller system gets a call from the school, it turns on and starts bringing BTUs in from that field. And think about all the infrastructure that it does not have to use anymore. It does not have to use any of that pipeline all the way back to the wellhead, any of the booster systems. We don't have to worry about any of that transportation, any of those assets, gas assets anymore to deliver BTUs to that school. So I think that's a really important point, and I am going to keep shouting that point out the top of my lungs for as long as I'm on here. And I have been doing it for 15 years now. In residential, it's a point that you have to get across to homeowners too, and it's a tough one to really grasp. And there's certainly argument. I mean, air source heat pumps, I think there's certainly a role for air source heat pumps in the mix for sure. There's no doubt. And certainly in climates and temperate climates and all that, they make a lot of sense. But in cold climates and variable weather conditions, and I mean, nothing beats the geothermal loop. And from a peak standpoint, and if you look back in my feed, I'm not sure if I posted it on my feed, but check out ontariogeothermal.ca, our recent study. From a peak standpoint, from a grid, if you're looking at a grid as a whole, geothermal can really save a lot of money for a grid scale adoption of electrification for electrifying space conditioning in buildings. And that's been, we just started laying that out in our first report that Dunsky Energy Consulting did for us recently, HREI and Ontario Geothermal. HREI commissioned it, and we sort of helped along with a bunch of information. So yeah, I think that's an important point. I don't want to go too long on this video, but again, the energy is right there, right in front of right below your feet, at point of use, on demand, whenever you need it. Let's just find a way to use it. Okay, check out my channel. Keep checking in. I hope if you like the content, and I'm going to keep building it up. My website behind me, jeffwhunter.ca, and appreciate you checking it out. Have a good night.